Lesson 5-6, Graphing Inequalities in Two Variables. I'm going to try and use the board tools to write with today. I'm at home sick, so do me a favor and bear with me. And I don't write quite as well with the board tools as I do when I'm at school. If you have any problems reading some of my problems, then I have, or if you don't quite understand something, I've gone to Khan Academy. Khan Academy, I hope you're familiar with. Oh, I have a keyboard. Here we go. Let's try using that. KhanAcademy. Okay? If you'll go to Khan Academy, they have some example problems of graphing inequalities in two variables. They're like a 2-minute quick study of one problem. They have like 3 different problems that you can look at if you want. So that's just a suggestion. So we've graphed linear equations. Now we're going to graph inequalities on the coordinate plane. There are 4 vocabulary words: boundary, half plane, closed plane, and open half plane. Please write those down. We're going to get to those definitions right away. Okay, so we're graphing inequalities on a coordinate plane, and it's going to be a shaded area. It's not going to just be a line. It's going to be everything on one side of the linear equation line, okay? So all of this will be a solution, this whole area, all right? And the solution is called a half plane, all right? If it's a closed half plane, sorry about that, if it's a closed half plane, the line itself is in the solution. So when it's a closed half plane, the solution is part of the boundary itself is part of the solution. When the boundary is not part of the solution, then it is called an open half plane. And the boundary is the line and equation that divides our graph into 2 half planes. So to graph a linear equation, there are 3 steps. The first thing you're going to do is graph the boundary. And you use a solid line when the inequality contains less than or greater than. You use a dashed line when the inequality when it says less than or equal to or greater than or equal to, and when you use a dashed line when it's just less than or greater than. So say our inequality was less than or greater than, then I would use a dashed line. See, I'm not very good with these tools, but I'm working on it, guys. Okay. All right, and that's our boundary. And we know it's just less than or greater than because it's a dashed line. All right, and then the next step is you pick a test point to determine if this side of the boundary or this side of the boundary is part of the solution. So the best test point to pick is 0, 0. All right? And you'll take your 0, 0 point and put it into your inequality. If you had x plus 2y is greater than 10, right? And you put 0 in here and here. Is 0 plus 2 times 0 less than 10? So the answer to that is that, yes, 0. If I put 0 in for x and 0 in for the y, and I solve that, I get 0 times 0, or excuse me, 0 plus 2 times 0 is less than 10. And yes, that means that 0, 0 is part of the solution. So therefore, I know to shade the part of the solution that the origin is in. If 0, 0 didn't satisfy the inequality, then I would know I should shade the other side, because 0, 0 wouldn't have been part of the solution. Okay, here's an example from the book. 3x minus y is less than 2. So our first step we're going to do is we're going to solve the inequality for y, get it in slope-intercept form. Okay, and then once it's in slope-intercept form, y equals 3x minus 2, then I can draw the boundary. And because it's just greater than, I know it's a dashed line. So let's graph this. Y equals 3x minus 2. Well, that means that sorry, I need a little pinpoint here. Let me get this one. So we start at negative 2, and we go up 3 and over 1, up 3 and over 1, right? Up 3. You guys remember how to do this? Of course. And then I make a dashed line. Better than that. Use a ruler, of course, you know. But I just can't do it very well on this thing. You get the idea. So we have this dashed line. Watch the guys at Khan Academy. They're really good at using these tools. Okay. We have a dashed line. Now we need a test point. Step number 2, right? We need our test point. And we're going to use 0, 0. Here's 0, 0, boom, right there. And we'll put 0, 0 into our inequality. And we find out whether or not 0, 0 is part of the solution. Once we've determined that, we find out that the half plane that contains the origin is part of the solution. So we will shade the half that the origin's in. The way you shade it is you just, you go, but don't cross over the lines like I've done, of course. Yours will be very nice and neat, I know. Okay, there's a couple guided practice. Good luck. Turn me back on when you're finished with those two. Okay, sometimes the inequalities say less than or equal to, as in this case, x plus 5y is less than or equal to 10. Okay, so we're going to solve for y, and we find out that when we do that, this is where it's really hard for me to do, and it takes too much time, so I'm going to let you guys do that, but we end up with something like y is less than or equal to 1/5 x plus 10 divided by 5 is 2. Okay, and then we can graph that, right? So we'll graph, we're at 2, this is m, so m is 2. I'm not going to write that out, that's too scribbly. M is 2, and the slope is 1 over 5, so we go up 1, 2, 3, 4, 5, and over 1. And down 1, 2, 3, 4, down 1, 2, 3, 4, 5, and over 1. And make our little line. But this time, because it is a less than or equal to, we're going to make a solid line. Again, and this time we pick our 0, 0 point, but this time we find out that the statement is false when 0, 0, we'll use 0, 0. So therefore, so 0, 0 is false, therefore we'll shade the other side. Oh boy. Yours are going to look much better than this, right guys? You'll shade the side opposite where the origin is, because the origin is not part of the solution. All right. Here's a couple of those for you to graph. And we are not going to do the last two slides. So here you'll just have four practice problems. We'll go over them in class, either Tuesday or Wednesday, whenever I see you next. And good luck with these. Again, remember, if you want to try going to Khan Academy, I have gone there and he has some very nice examples of graphing inequalities in two variables. Good luck.